Hello, everybody. I hope you are doing well. This is the Sunday video for November 8th, 2020. Well, your test 4 is over, and so is the election. Election day is come and gone, and so now we can focus on your mathematics, right? All right, so we're going into week number 12, and as you can see my background, this is actually right at the bottom of the College of the Canyons library. There are stairs going from the faculty parking lot up to the library building, and we can see the changing colors even in California. So welcome to fall, and now we are going into week number 12. So we have only about a month left, and just so you know, our final exam is scheduled on Wednesday, December 9th. December 9th. It's pretty much like, a month or so. Okay, so let's see what's going on this coming week, and I will let you know what's going on in the next few weeks. All right, let's get started. I will share my screen here with you. Okay, so this past week you took your test number 4. Okay, you had practice test 4, and then your test 4 was taken and has been graded. Your answer or well, your score should be already posted in Canvas. All right, so this coming week, you are going to get started on our last chapter of Calculus 3, which is chapter 6. And we will be studying this new concept called vector calculus. All right, vector calculus has to do with a new type of functions called vector fields. So you'll be studying vector fields in section 1. Section 2 is line integrals, and section 3 is specific kind of vector fields called a conservative vector field. I just want to warn you, section 1 is short, section 3 is rather short, section 2 is not. Okay, so in section 2 of chapter 6, you will be learning different types of line integrals. So be prepared. You're going to spend a lot of time this week on sections in section 2. Okay, so I think we have like more than 3, maybe 4 segments to lesson video for section 6.2. So just be ready and prepared that you will be spending a lot of time on section 6.2 this coming week. Okay. Now, before we talk about chapter 6, though, I want to just go back and say something about this test 4. Most of you did fairly well, but there are some things I noticed, some observations I made, which I feel is necessary for me to share some of these observations with you. There are certain things that many students are doing that sort of bothered me. So let me change the screen, and then let me share some of the thoughts with you. All right, so the first thing is this idea of orientation. Now, I've never really had an issue with my years of teaching Calculus 3, except for some reason, while I was grading test 4, I saw several students using different orientations. Okay, now, you know that I have always been using, I hope you know this because I have been, drawing this many times throughout the course. We use this right-hand orientation where x is coming, toward us as you draw this picture, and then y goes to the right and z goes on the top. All right, and this is called the right-hand orientation because if you put your, index finger in the x direction, and then you try to wrap it around in the y direction, sort of like this, and then your thumb is going to go up if it's your right hand in the z direction, and this is called the right hand orientation. This is the standard orientation. It is the most conventional one, and as far as I know, every calculus book I have ever seen uses this orientation. I want you to use this, okay? This is the standard. Now, I realize that some people prefer to look at the three-dimensional space from different point of view. So for instance, some of you are using this this orientation where x goes to the right, y goes toward the back, or toward the back side of the paper, and then z still goes up. Now, this is sort of okay. It's the right hand orientation, right? In other words, if you use your right hand as you wrap your fingers from the positive X to positive Y direction, your thumb will be still going up. So this is the right hand orientation. However, and by the way, this does have an advantage, because we normally see the XY plane like this, right? This is a positive x-axis, this is a positive y. And so it's natural to go from here to here. I mean, you're looking at this from here, your eyes over here, you're looking at, this way. So it sort of makes sense to have this picture as your XY plane like this. But the problem is it's not used by most people. And so you may think, well, I'm going to start my new movement. Okay, you could. The only problem is if you're the only one using this, and especially if you go into a four-year university and you start using this convention, you can get things marked incorrect just because you're using the wrong orientation. So I ask you to stick to this orientation. All right. Now, I also noticed that several of you are using this left-hand orientation where you switch X and Y axes, and Z is, of course, going on top. Now, notice here, at this point, you have switched the orientation. This is called the left-hand orientation because the right hand doesn't give you this. And this is definitely a no. Okay, now in trigonometry, we use the counterclockwise direction to measure angles, right, in degrees or radians. So this is called 90 degrees. If you go the other way, it's called negative 90 degrees. So who decided that the clockwise orientation is negative and the counterclock orientation is positive? I don't know who that is, but somebody decided to do that, and pretty much the whole world agreed to do so, okay? So for the same reason that we go counterclockwise direction as a sort of a standard notation or a standard orientation for measuring angles, for the same reason, I would ask you to use this standard and conventional orientation when you draw or sketch a three-dimensional space, right? Don't use this, even though this is still the right orientation. You can use this for your own view if you like, okay? But if you are writing an answer, or if you're drawing a picture for an answer, make sure you use this and not this, and definitely not this, okay? This is what happens if you look at this picture in a mirror, okay? This is a mirror image, and in a mirror image, and by the way, you can also ask this interesting question: why does a mirror switch the left and right? And the answer is the mirror actually doesn't switch left and right. It switches the front and back. And it is, in mathematics, it's called a reflection. You may study this when you talk about matrices in linear algebra, but it changes the front and back. And when the orientation, the front and back orientation switches, then the left and right change. It's also an interesting question in linguistics. How do you define left and right? Because if you stand upside down, or if you put your mirror on the bottom of you, then the orientation changes. Okay, so, but that's a different issue. Right? The conclusion here is to make sure you use the conventional XYZ axis in this drawing. The second thing is, okay, so you can see here, and what is this, by the way? This is the triple integral showing you the volume of the unit sphere, radius 1, and it goes from top to bottom, and then it goes all the way around, right, from 0 to 2 pi. The way I evaluate this, as I evaluate any integral, triple integral, is from inside out, right? So you do the inside first with respect to rho, and then phi and theta. Now, several of you, I noticed as I graded test 4, have a tendency to separate these things as three different integrals multiplied together. Okay, now this is okay occasionally. And of course, this is okay if and only if there's a part that depends solely on theta, there's a part that depends solely on phi, and so on. But in general, this doesn't work. Okay, you can't really separate it this way. And so I don't encourage you to do this, okay? In fact, I strongly discourage you from separating these variables in integral. There's nothing wrong with doing it this way, okay? And as an example to other people, you should always go from inside and work your way out. And so that is my recommendation. I highly, highly suggest you do it this way and not this way. Okay, it is a bad practice, and occasionally it could work. And on this test, it worked. Okay, anytime you had a spherical triple integral, this worked. But please do not do this anymore. All right. And speaking of triple integrals, the order in which you see a spherical triple integral is almost always this: d rho d phi d theta. Remember that dv is rho square sine phi, and then the rho d phi d theta. And you can sing that if you like. But this is, again, the conventional. Now, it is possible to switch these, and some of you have switched these occasionally, but I don't like you to switch these unless that's an absolute necessity. All right, because again, conventionally, everybody uses this order: d rho, d phi, d theta. The same thing applies to cylindrical coordinates. In cylindrical, dv is r, dz, dr, d theta. Some of you have switched, some of you switched these, some of you even switched these, and sometimes those are okay. But in the conventional use of cylindrical coordinates, it's almost always dz, dr, d theta. So even though, and I believe in freedom, mathematics is, and in fact, the famous mathematician George Cantor, the founder of set theory, famously said, freedom is the essence of mathematics lies in its freedom. The essence of mathematics lies in its freedom. So you are free to create a new concept, to study new mathematical structures, and you should be free indeed. Okay. However, when there is a sort of a universal agreement on how to do things, in order to not to be misunderstood, okay, in order not to be misunderstood, it is very wise to use the convention that is used everywhere, such as the order of these order in which you integrate, and the orientation. All right, so that's what I wanted to share with you, having graded test number 4. All right, so a couple of things here. I don't know if you have, if you listened to the speech by the President-elect Joe Biden. I'm not making any political statement here, but I want you to know, you heard him referring to inflection points. Did you catch that? Yeah, I mean, so Joe Biden in his speech talked about, the fact that we are in this inflection point several times. Okay, so I thought, oh, this is a great thing to talk about, right? What is an inflection point? What is he talking about? Okay, I believe he's talking about, the fact that we have been going concave down. Now it's time to bend the curve and to make it concave up. Right? You've been turning this way. Now we're going this way. Right? So I think that's a great reference, and you understand that, right? So I hope that you appreciate the use of, or the metaphor related to calculus in political speeches. And so I thought that was awesome, and I had to mention this. And one more thing, you may have heard that this is Sunday morning. I'm recording this, and many times I ask you, like, I show you an integral, I show you a triple integral, like the one I just shared with you, and then I ask the question. Here's the answer. What is the question? And the question may be, what is the volume of the sphere of radius 1? And I call that the Jeopardy-like question. And again, some of you may have already heard this, but unfortunately, the longtime host of Jeopardy, Alex Trebek, passed away this morning at age 80 from the pancreatic cancer that he had been suffering. So rest in peace. He is one of the people that I admire and I just love to watch for probably more than 3 decades now. So, rest in peace, Alex. All right, so as far as your calculus is concerned, you have those 3 sections to study this week. And then I have created new study groups. And so reach out and try to work together. It always helps to get to know your classmates, even in an online environment. Eventually, I'm going to use the discussion boards. I believe I'm going to start using discussion boards for extra credit. So I'll be asking questions on calculus involved or calculus related questions on discussion boards, so we can have some active student to student contact. All right, but I'll let you know about that later. All right, have a great week, and I will talk to you later. My office hours are still on Monday and Wednesday, 1 to 2:30, and I will keep those office hours for the rest of the semester unless otherwise noted. All right, so have a great week. Take care. Bye.